All right, so section 3.5 is derivatives of trig functions. So some of you guys were emailing me and you'd already started on your take-home test and you realized that, hey, I don't know the derivatives of these functions. I think Rachel Hahn was one of them. So we're going to learn those today. There are many derivative formulas you're going to need to know. You need to memorize all of these that you're going to learn. They will be on your test a million times, so you need to make little flashcards. All right, hopefully by now you guys know the derivative of sine. It is cosine, right? We talked about the curves and how the slope was related. And then the derivative of cosine, do you guys remember that? Negative sine, right? All right, so number one says find the equation of the tangent line to y equals 2 times sine of x plus cosine of x at 0, 1. So we've done this kind of thing before. So y prime equals the derivative of 2 sine of x is going to be 2 cosine of x. The 2 is just basically out front. You could do the product rule, but we talked about this on that homework problem. If you did the product rule, it's derivative of 2 is 0 times sine of x plus 2 times derivative of sine is cosine of x. So this part ends up not mattering, right? Okay, so then we get plus derivative of cosine is negative sine, so minus sine of x. We want to know at the point 0, 1, so if I'm finding the slope at the point 0, 1, I need to plug in 0 for x, because my x value is 0. So I have 2 cosine of 0 minus sine of 0, and you've all memorized your unit circle, so you guys know that the cosine is what value? Cosine of 0 is 1, and the sine of 0 is 0. So your slope is 2. It's at the point 0, 1, which is convenient because that is a y-intercept. So it's just y equals 2x plus 1. And that's it. Oops, missed it. Oops. I don't know where I'm going. Okay, so use the quotient rule to find the derivative of the tangent function. So back when I was in college, I applied for a job at a tutoring center. And it'd been a long time since I'd taken Calc 1. And they had all these questions about the derivative of tangent and also the antiderivative of all these different things. And the way I remembered it on that day is I was like, oh, well, I can't really quite remember what the derivative of cotangent is, but I know that cotangent is cosine over sine. And then I used the quotient rule, and I figured it out. So you guys can always do that. I wouldn't recommend it, though, for your AP test, because what did I tell you about my AP test? What happened to me? I ran out of time. So don't be doing the quotient rule when you can have these things memorized and you can know them with the snap of fingers, right? Okay, so if I'm finding the derivative of tangent, and I really did just forget, or I'm freaking out on the test and have no idea, so y is equal to tangent of x, which is sine of x over cosine of x. If you can't remember that, you're really in trouble. So take the quotient rule. So low is cosine of x, d high is derivative of sine is cosine, minus high, d low, so negative sine, all over the square of what's below. So the top becomes cosine squared plus sine squared. Hopefully after having a whole year of pre-calculus, you guys know that cosine squared plus sine squared, or sine squared plus cosine squared, is what? 1. So you get 1 over cosine squared x. Well, what is 1 over cosine? 1 over cosine is? No. Secant. So this is secant squared x. I always remember the c's and s's go together. So cosine is the reciprocal of secant. Cosecant is the reciprocal of sine. Okay, c's and s's go together. Secant is 1 over cosine. Cosecant, 1 over sine. SC. Now don't get them confused with cosine and sine. As long as you know that cosine and sine are not reciprocals of each other, you're good. All right, next up. So here are our formulas. The first ones are easy. We talked about those. So derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent we just found is secant squared. If you can remember those three, you are golden. Because there's a relationship. So if I see cotangent, I know it's negative cosecant squared x. Secant, well, I guess those aren't the three you need to know. Secant is secant x tangent x. And cosecant is negative cosecant x cotangent x. So let's look at these two in particular. These two in particular. And these two. Do you see a pattern? Opposites? Which ones are opposite? The ones that start with co, right? Do you guys see? Cosine, cotangent, cosecant, those are the ones that have negative. And then do you see if you had sine, the derivative of sine was cosine, derivative of cosine was negative sine. So they switch. If I have secant and cosecant, kind of sound the same. You got it? See how it's working? Okay, use those when you're memorizing. So use those patterns. Okay, so I said whenever I forget these derivatives, I just quickly use the quotient rule and derivative of sine and cosine. However, you don't want to do that. It's why waste time on your AP test figuring them out. Okay, differentiate f of x equals secant x over 1 plus tangent x. Okay, so if I'm taking the derivative, f prime, so you do your low d high minus high d low, all of it square, what's below? Okay, you should get that. So 1 plus tangent x times secant x tangent x minus secant x secant squared x all over 1 plus tangent x quantity squared. Okay, look for different things that are in common, maybe on the numerator. I'm trying to find when it has a horizontal tangent. So I'm trying to find when my slope is equal to 0. All right, and usually when you have 0 equals something, you want it to be factored. So we want to keep this factored. So the denominator, I'm still going to have 1 plus tangent of x squared. And the numerator, what do they all have in common? Like each piece? Kind of weird to see, but I mean, you could bring this secant x tangent x into both of these. But then did you see everything would have secant x? Okay, so we're going to use that. So we're going to pull out a secant x to the front. So when I do that, I'm going to have 1 plus tangent x times tangent. So let's go ahead and distribute the tangent. So I'm going to have tangent x plus tangent squared x minus secant squared x. You see that? All right, and usually when I'm seeing like tangent squared, secant squared, things like that, I'm thinking of the Pythagorean triples. Now, do you guys remember how to get all the Pythagorean triples? So you start with sine squared x plus cosine squared x equals 1. Okay, what would I divide each term by in order to have something that has secant? So secant is 1 over cosine. So if you go through and you divide every single term by cosine squared x, you get tangent squared plus 1 equals secant squared. So what is tangent squared minus secant squared? Negative 1. Do you guys see? Tangent squared minus secant squared, you're going to bring this over here, and then bring the 1 to the other side, so subtract it over. So tangent squared minus secant squared is negative 1. So we now have secant x times tangent of x minus 1 all over 1 plus tangent of x squared. Is this reminding you of Pythagorean identities? Do you guys remember those? Everybody always hates those in pre-calc. So we're trying to find when it's equal to 0. So we're trying to find when secant x is equal to 0 and when tangent of x is equal to 1. So when is this equal to 0 and this equal to 0? So then the whole thing would be equal to 0. All right, let's just go from 0 to 2 pi. I didn't really tell you where, but let's say on 0 to 2 pi. Okay, when's tangent equal to 1? Close. Not all of them. So it's not pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. It's just 2 of them. 5 pi over 4 and pi over 4. Because think of your unit circle, guys. When are sine and cosine exactly the same thing? Because tangent is sine over cosine, right? So you're saying when is sine and cosine the same thing, so when I divide them I get 1. So they're the same thing at this point and at this point. So when they're both positive, positive, or negative, negative. Okay, so that's at pi over 4 and 5 pi over 4. Okay, now when's secant x equal to 0? So what is secant? 1 over cosine. So we're saying, when do we have 1 over cosine of x equal to 0? It doesn't happen. Do you guys see? Doesn't happen. So this is, nothing comes from there. So it's only at pi over 4 and 5 pi over 4. So if you guys draw secant x, like go ahead and get out your calculator and see what secant of x looks like. I'll graph it on Grapher so you can see. You're saying it's never equal to 0, so let's see what that means. Secant x. So in your case, it's going to be 1 over cosine of x. It never crosses the y-axis. So secant of x is never equal to 0. Do you guys have those little u's? So it never reaches a height of 0. All right, next up. So it says an elastic band is hung on a hook and a mass is hung on the lower end of the hook. Okay, these are always weird to think of, but very physicsy. Okay, so we have this band, and we have some kind of weight on the end of it. So here's my little hook. When the mass is pulled downwards and then released, it vibrates vertically. So it's going to go up and down, up and down. Your equation of mass is 2 cosine t plus 3 sine of t, where t is greater than or equal to 0. So it's time, so it has to be greater than or equal to 0. S is going to be measured in centimeters, t is going to be measured in seconds. We're going to take the positive direction to be downwards. Okay, so when I talk about this way, I'm going to say like 2 feet, and then if it bounces back, it would be like a negative number of feet, okay? I guess not feet, centimeters, right? Okay, find the velocity and acceleration after 2 seconds. So how do we find velocity again? How's it related to position? S prime, right? So S prime is going to be velocity. So it's going to be, derivative of cosine is negative sine, so it's negative 2 sine of t plus 3 cosine of t. Acceleration, that's S double prime, so the derivative of velocity. So it's negative 2 cosine of t minus 3 sine of t. Okay, those are our functions. It says how far from its equilibrium position does the mass travel? So how are we going to solve for that? What do we need to do? Think about the spring as it's, or the spring or the elastic band or whatever it is. As you're pulling it down, it's going to stop down there and it's going to pop back up. So we're trying to find when it stops, right? And then what will we do with that t value? So once we find when it stops, it says how far, so when you see far, plug it back in for the position. Okay, so we're going to find when velocity equals 0, so it stops and then heads backwards, heads back. Then plug in to position. So whatever number you get, you're going to plug it into the position function. All right, so when velocity is equal to 0. So we have -2 sine t plus 3 cosine t. And you can try to solve, and you're going to get some weird numbers. You're not going to get numbers that we know from our unit circle. So let's go ahead and we're going to find this on our calculator. So go ahead and graph -2 sine t plus 3 cosine t for y1. And we want to find the first location when it pops back. So the first place it crosses the x-axis after time 0. So we're going to do second trace, and we're going to find the 0. When it says left bound, you get on the left of it. I think yours usually say lower bound and upper bound or something. Or does it say left and right? I think the new ones say left and right, actually. I got 0.9827. Do you guys get something like that? Let me go back again. Okay, keep that number in. So keep the number in your calculator. It won't move? Try right and left instead of up and down. Okay, so what I have on my calculator is a sinusoidal function, so like one of those wave functions. And it's crossing the x-axis somewhere around here. And that number, when I did 0, I found x equals 0.98279,372. 1.2 something? Did I graph the wrong thing? Okay, so check what you put in, or check your mode, maybe. Radian mode? Are you in radian mode?
I just zoomed in for when I did it.
It shouldn't be that far off, though. Okay, now I want you guys to store this number, and this is an important thing to know for your AP Calc test, because a lot of times you're going to use this number throughout your problem, so you don't want to round early. Make sense? You want to round at the very end. So we're going to do second quit. So do second quit, and then hit the X button and hit enter. Do you see how that number comes up? Isn't that nice? So basically, anytime you're do second quit and then hit the X button, and it will come back up. So anytime you want to use this button, you can use X. But what if you needed to go back into your graph and do another intersection or something? It would use that new X value. So we're going to store it. So do you guys know how to store things? So we're going to do stow. See the button that says stow? S-T-O with a little arrow. So hit that button, and it's taking that number from our answer, so from X, and we're going to store it as a letter. So store it as alpha A. And then on your AP test, I want you guys to write A above it or something, so they know that you have stored that as A. So T equals 0.98279, and we've stored it as A. So now if I want to find how far it was, I'm plugging into my position function. So I'm going to do S of my A value, and you can just write S of A as long as you know that you've stored that as A. And my position function was 2 cosine t plus 3 sine t. So 2 cosine of whatever A is plus 3 sine of whatever A is. And I'm going to put that into my calculator. So 2 cosine and then pull up alpha A plus 3 sine alpha A. When I do that, I get 3.606 centimeters. 3 decimal places on the AP test. So you don't do 3 decimal places until you're at the very end of your problem. Okay, C. It says, when is the speed the greatest? Now, we didn't talk about this in the last section. I kind of went back and forth on it, but there's different words in calculus and they mean different things. Like distance and displacement are different from one another. So on the cross-country team, if I start at the school and I go out 3 miles and then I come back 3 miles, the distance that I have traveled is 6. How much have I moved from the beginning point? 0. So distance and displacement is different. Speed and velocity are also different. Whenever you hear speed, it's the absolute value of the velocity function. So speed is always positive, velocity can be positive or negative. Velocity is basically representing what direction you're going in. Speed is only talking about how fast you are traveling. So we're trying to find when the speed is the greatest. So we're going to find the derivative of our velocity function, which is the acceleration. We want to know when the velocity is maximized or minimized in this case. So does that make sense? So if I graph the velocity function, I want to find when it's at its highest or its lowest. And I want to find the biggest value for it. Okay, so let's do that. So I'm going to find v prime. So find v prime, which is the acceleration, find when it's equal to 0. So to find the max or min. Okay, so my acceleration is equal to 0. Well, let's figure it out. So negative 2 cosine t minus 3 sine t. Let's put that in for y2. Oops. And you can unhighlight y1 so it doesn't show up on your graph. It's kind of confusing when you have 2 of them. On the no calculator section, not one where it wouldn't be nice numbers. This is definitely a calculator type question though. They always ask these types of things where you need to relate 3 different functions. And okay. Okay, we're going to find the first 2 places. Okay, so I have some kind of curve. Where's mine? So I'm finding, oops, mine didn't look very good. I'm finding this spot and this spot. So the first one I get 2.5535901, and let's save that as B. So exit out, so do second quit, store as B. Well, hit X first. X, store, oops. Okay. What? Yeah. It's this little point right here. Okay, now find the other place where it crosses the axis. We're trying to find the max or min of the velocity, so we're looking at the acceleration function. We're saying, when did you stop accelerating, basically? So, so think about velocity. If I had the velocity function, I'm trying to find a max or min. The slope of that is 0 there. So the slope of velocity is acceleration. So we're finding when the acceleration is equal to 0. So this graph that I have is acceleration. All right, now this other value, anybody get that one? 5.69 something. Yep, 5.6951827, something like that. Okay, we're going to call that variable, or that number C. So second quit, hit X, store as B. Hitting the wrong button. Store alpha B. Oh, I just stored it as B, dang it. I just stored it as C. Did you guys store it as C, or you just listened to me? Store it as C. Just lost my B value. All right, so we want to find what the velocity is at each of those locations, and we're not worried about whether it's positive or negative. We're just finding the absolute value of it and which one's the biggest one. That would be the greatest speed. So we're going to plug into our velocity equation. So velocity is -2 cosine t minus 3 sine of t. Now I'm going to plug in 2 points for that, 2 t values. So I would put that in for y3. So -2 cosine of x minus 3 sine of x. And then I'm going to go to my table. And on my table, under x, I'm going to plug in those 2 values. So I'm going to do b, so alpha b. It puts it in there. Do you guys see how that works? And alpha c. In my case, I stored them as the same thing.
Isn't that the same one that we already had?
What?
The same equation.
Yeah.
We already had one in there? Oh, it is, yeah. Was I doing the wrong one?
What comes out of here?
Yeah.
Oh, so plus, sorry, yeah. So -2 cosine of x plus 3 sine. That's the velocity equation, right? We want to plug it into velocity. So under y3, put -2 cosine of x plus 3 sine of x. Okay, it's under y1 already?
Yeah.
Yeah, okay. Yeah. Okay, so what do we get when we plug in those values? So you get you don't actually have to round up on the AP Calc test. See how I just erased that and made it 4, like 2.554. You can actually truncate, so you can just chop it off too. So 2.553. All right, and that when you plugged in that number, that exact number, you guys got what? -3.328 or something.
I got 6.
Okay, I'm confused. What are you telling me? So what is the velocity? Tell me the numbers. -3.606. Okay. And then the velocity when you plug in 5.695, all of that. So all of those numbers, what do you get? 0.6056. So what's the 3 point? So they're the exact same thing, right? Are they the same thing? Which would make sense because it is oscillating. We don't have like air resistance or anything, so it's just going to keep going back and forth. All right, so that means that the greatest speed is centimeters per second. So 3.606 centimeters per second. Okay, number 3, find the 30th derivative of the sine function. Sorry, they're going to a college day. So, or 5 minutes. 30th derivative of the sine function. So let's start with y equals sine. Y prime is derivative of sine is cosine of x. Y double prime is negative sine. Y triple prime is negative sine, so negative cosine of x. And then y to the fourth derivative. We don't do 4 dashes, 4 primes. We do parenthesis 4 parenthesis like that. So we know it's not y to the fourth, it's the fourth derivative. Because it gets a little ridiculous when you talk about the 30th, right? So that derivative would be what? Sine of x. So it's back. Now think about it. When will it be back to sine of x? Every 4. So y to the 8th is sine. Y to the 12th is sine. So when I'm going up to 30, it's going to be y to what power right before 30? Or not power, but what derivative? 28, right? It's every multiple of 4. Oops. Sorry. So it's going to be y 28 is sine. So that means y, the 29th derivative is cosine, and the 30th is negative sine. See how you can figure those out? So you don't have to do all 30 of them. Please don't. I think there's one like that on your take-home test too. Okay, and that's the end of the second one.